Boy, losers. I eat losers for breakfast. Breakfast? It's not breakfast. Breakfast can be good for me. No, stay focused. Speed. Faster than fast, pretty quick. I am lightning. Hey, listen, you ready?
Oh, yeah. Faster than fast. Quicker than quick. Speed. Alright, so the struggle bus is real. Let's do it. What's the one thing that I know based off of this problem?
66 feet per second.
What's moving at 66 feet per second? Okay, but what's moving on this diagram? What's moving at 66 feet per second? Bestie? No. Call that a chain. What? What part of the wheel?
See, I can tell you that.
What part of the wheel is moving at 66 feet per second? Where's the tire? No, where is the tire? Okay, so what part of the tire is moving at 66 feet per second? The entire tire is not moving at 66 feet per second. The what? The outside edge of the tire is moving at 66 feet per second. The inside is not. Just so you know. What?
Why is the inside not moving with it?
Because it's a linear speed. If I spin this Ferris wheel up here, okay? If I spin this Ferris wheel, the outside, so if I go 1/2 of a rotation, right? My finger has to go all the way around to here to go 1/2 of a rotation, right? But if I go inside, that same distance is now only that far. So out here, it's, let's say, 12 inches of moving. In here, it's maybe an inch. It matters where you are on the tire if you're talking about linear distance.
So it changes
How far out you go, the farther you go in distances. Yes. Okay? So this is the outside of the tire. Tires are going that way, so that's this out there. Okay? What do we need? What do we need?
angular speed.
Angular speed of all three of them, right? Okay. Angular speed is speed in radians. Okay. So that's in radians per second. Okay. So, how do I get from feet per second to radians per second? Of the wheel. Let's go of the wheel. Bestie.
We have to take 66. Yeah, that. And then times 12 inches over 1 foot.
Okay.
And then times.
Hold on. So 12 inches over 1 foot takes me, is that still linear speed then?
Yeah.
Okay. Keep going now, yep.
Okay, and then times 1 radian over 14 inches.
Why did you pick 14 inches of the wheel? Yes. Okay. So that puts me in radians per second. Love it. When I reduce that fraction, I get 396 over 7 radians per second. Would you agree with that? Yeah. Don't want to round it yet to, what is that, 59.3 or something like that? Yeah, that too. What's up?
So will it matter if we have it in that form, like in fraction form, or in?
It will tell you on Tuesday if we want it exact or not exact. Okay? But this one, I'm going to still use coming up here. So that's why I'm definitely going to keep it in exact. Okay? So that wheel is spinning around at 396 over 7 radians per second. Right? Angularly. Okay? So now let's go to the inside. Because this sprocket, this little sprocket, the small sprocket, is connected to it, right? So what is the angular speed of the small sprocket? Nope. What is the angular speed of the small sprocket? Right. Nope. Why is the small sprocket also spinning at 396 divided by 7 radians per second? Bestie? Because it's angular speed, it's not linear speed. So those two are on the same axle, right? They share the same center point, okay? So everything that's spinning is spinning on that same center point, is spinning at the same rate. So what two are the same? What two speeds would be the same? Rotational and angular speed are the same if they share a center point. Linear speed is different. Okay? But those two share the same rotational speed and they share the same angular speed.
So the 66 feet per second, what is that?
That's the linear speed of the outside of the tire.
So how can we use the linear speed of the outside to calculate the small sprocket if it's different? You know what I mean?
But they're on the same axle.
But you said that the further you go in, the linear speed
That's-
changes.
But that's linear speed.
Right, so if we're using linear speed to calculate the angular speed, don't we need the linear speed of the actual small sprocket?
Not yet. Okay. Right? Because the outside is spinning faster than something closer to the center. Because it's got to go a farther distance in the same amount of time. Okay?
Yeah.
Right?
Also, like the radius of both of those circles, since they're on the same axle, is going to relate the streets of the two, so you can kind of.
Like, what do you mean?
Like, I was just trying to help.
Oh, okay. I gotcha. But yeah, but we're not quite there yet because we only needed the wheel radius so far to get to the angular speed. Okay. All right. So now I'm sitting at this. I've got the small sprocket. Okay. I need to get to the big sprocket. Okay? So, how's the small sprocket connected to the big sprocket? By the chain, right? So, that's the only way that I can get to the other sprocket, is by something that it's connected to. Well, it's connected to the chain. So the chain is going around the set of two sprockets, correct? Is the chain always moving at the exact same speed? Everywhere on the chain. Always moving at the same speed. Which kind of speed is it moving at the same speed of? Linear speed, right? So I need to take this angular speed, which is spinning at 396 radians for every 7 seconds. And I need to convert that into a linear speed. Because that's going to be the linear speed of the chain. So how would I convert that into a linear speed of the chain? I'm on the small sprocket. Small sprocket is spinning at 396 over 7 radians per second. Need to convert that. Multiply it by 1.5 inches is 1 radius of that small sprocket. That would take my radians and cancel them out. Do we agree that that is now the linear speed of the chain all the way through? Correct? Okay. So that now allows me to come off of the small sprocket and onto the big sprocket, because they're connected by that chain. So that chain is moving at whatever that is, inches per second. Okay? How do I convert that linear speed now to the angular speed of the big sprocket? And now I'm back into radians per second, correct? And I'm on the big sprocket. .5 goes into 4.5 3 times. 3 goes into 396 132 times. So that leaves me with 132 over 7 radians per second of the big sprocket. Okay. We have placed the electronic textbook on It's Learning, because we have also placed some selected problems out of said textbook on It's Learning. I strongly recommend that those problems be done prior to Tuesday. Okay? More practice, more practice, more practice. worksheet is also practice for you and will be collected, the goldenrod worksheet will be collected from the 85 percenters or anybody else that would like to turn it in. Okay? Yes, Betsy.
Is there anything else being collected?
We collect anything that's on gold now. We color coded ourselves. Okay? Other than the formative that we took,
You're not collecting the worksheet and the last one.
so only on gold.
So this is the first one we got.
This unit, yes, this section.